Yeah, thank you for the introduction. I'm Björn. I have chosen a somewhat cheesy title for that talk, but it essentially means I will talk about alerts and noisy pages. As said, I work at SoundCloud, so that is a company that puts sounds into the cloud. You might have heard about it. We love sound, but we also love orange for some reason. So all my slides are kind of orange. Usually I wear an orange t-shirt, but I thought I'd show a bit of shirt sympathy with yours, so I have a shirt now. Okay, so now I have to switch on my clicker. It even works, technology. So SoundCloud is perhaps a bit smaller than you think. We are like about 100 engineers, a bit more perhaps. That's just the order of magnitude. I'm a team called Production Engineering. That's about 5% of the company, so that boils down to like 5 people or something. This is completely different, I guess, from production engineering at Facebook, and it's also different from SRE at Google. We are a team that runs the system that runs all the other systems, i.e. something like cluster management. We're also in charge of monitoring, as just said. Prometheus had the cradle of Prometheus was essentially our team. By now it's a huge open source project with a lot of development all over the place. But that's where it kind of started. So I will be kind of biased towards Prometheus, but this talk is monitoring system agnostic. So this is all just lessons that you could apply with any monitoring system. Obviously more modern ones, we already learned about Bosun, Prometheus, whatever, might be more able to apply those lessons. So Prod-Eng, it's not really SRE, it's not really production engineering Facebook style. Why so? So SoundCloud has an operation model that boils down to you build it, you run it. If you're a developer team and you build a product, you have to run it, you're on call for it. You are also the ops person, and that's why I also like to call it true DevOps, because the devs are also the ops. It's not just that devs and ops get nicer along with each other. Some people call it no ops, not because there's no operational work anymore. Unfortunately, pretty much not so. This is no ops because there's no dedicated ops team. And also Prod-Eng is a team that builds a monitoring system, or we build a cluster management system and then we run it, we're on call for it, but we're not on call for like product teams. We might consult them, but yeah. It's also, if you look at the scale, if you have 5 people and you have a company like SoundCloud with like many different interfaces to the public, that's just not scaling to it. You can't have a team for all of that. That's pretty differently at Google, and that's a company I worked for as well. Up to 3 years ago, the gentleman that just gave the talk we heard, Niall, he was my boss, and I'm really thrilled to give a talk just after my former boss. So Google is 2 orders of magnitude larger. It has an SRE team, which more or less 5% of the engineering population, probably a bit less, I guess. It's just wild guess, right? So the scale, the proportion is similar, but the scale is completely different. And that justifies a lot of different approaches, I guess. So I was one of the real SREs back at Google in ads. Google obviously is doing SRE by the book because they have invented it, and by the book is, as you all know by now, is to be taken literally because there is a book, right? So at the cover you see Niall Murphy again. He's haunting me. So
I have much better skin than that guy.
I love that book. I'm a fan, and you can see that on the very first page, where not the first real page, the page with the testimonials. This is my holy scripture, essentially, right? That's really great. The funny thing is that SoundCloud, as just explained, has a different scale, has a different model of operation, but still you can apply so many lessons from that book to SoundCloud as well. And that's kind of the same hope I have for this talk, that I'll cover SoundCloud as the poster child or as a use case or whatever. And I will also tell a bit about Google. So we cover a broad range of different sizes, different operational models. So I hope there will be lessons that are applicable to your situation as well. Same as the SRE book applies to all of us, I guess, in many ways. This talk is pretty old in a way. I planned it, or I gave it as an internal talk at SoundCloud to teach my colleagues about alerting and non-noisy pages. But then the book came out, and I realized I could kind of put a quote from the book onto every slide, and this is which I will do copiously. It's like, it's so nice, you have a holy scripture, and you can drop quotes from it, and it confirms your own preconceptions. I mean, you should never do that with real holy scriptures, of course, but yeah, it's probably okay with a tech book. Okay, so now let's talk something. Let's talk about scalability. Your site, if you have a healthy business, grows in traffic, and if you have a healthy developer team, you also launch new features, right? So I pretend you could just multiply those two things. So when is your business scalable? People would say, let's imagine the y-axis is the effort you need to run your site, some units of effort. So if you increase traffic and complexity, and that scales linearly with the effort you have to invest, people would say, yeah, that's scalable, right? And a scalability wall is something like that, right? If you increase your traffic by 10%, and then you have twice as much effort to run that, you are not scalable. So now if you put on the y-axis something like operational load, or in particular in this context here, pages, I claim that even the linear graph is not scalable. That's because your user growth is hopefully exponential. You will hopefully launch a lot of features. So next year you might have quadrupled that product, and then times 16 in 2 years, and then you get 16 times as many pages, or you have 16 times as many ops people or teams. So that just doesn't scale. What you want is something like that. If you increase your traffic, you want a sub-linear growth in effort, at least in stuff like human intervention, operational load. And that's essentially the baseline of the famous 50% law of Google's SREs, which is also in the book, obviously. So any SRE should have at least 50% of their time to work on non-toil, non-operational issues, to work on something that makes operation easier and scale better. Okay, now let's look at SoundCloud 3 years ago. Every proper startup of the last decade starts with a monolithic Ruby on Rails app. That's one of those laws, right? So, and then you realize, okay, I launch more features, I get more users, and you run into the scalability wall from the previous slide. So you have to do something, and SoundCloud, pretty much as a poster child for that, migrated to microservices. Now, microservices are not a silver bullet. On the contrary, they create new and more interesting problems and many opportunities to fail. A lot has been said about this move, and we will here focus, obviously, on alerting and monitoring. So the dynamic nature of a microservice architecture makes it really hard for traditional monitoring systems to make any sense of it, right? So your alerts become less meaningful. You have more trouble to even diagnose an incident if it happens. This cartoon here is actually from Bora's talk, a colleague of mine who will give a talk later today. And this should symbolize an outage that is kind of interesting and difficult to diagnose. So this is already troublesome, right? And then there's something like Conway's law of alerting. I mean, I made that up, but Conway's law is often quoted in connection with microservices. You have like small independent teams, so you have an architecture of microservices, and that mirrors each other. But this is also mirrored into your alerting and on-call organization. So you have very small, we had that at SoundCloud. We had like on-call rotations of 2 or 3 people, and they were on-call for like 1 or 2 microservices. So being on call almost all of the time is really bad, but it sounds really good to be on call for a really small, tiny fraction of your gigantic production system, because you know that really well, and then you don't get paged so much because you're only on call for such a small number of systems. That's actually not an advantage, that's a trap. Because it masks the fact that you have noisy pages, because you think you have the illusion you can handle that, because you only have this small system and you also know every single alert pretty well. And also, if you think we should increase the on-call rotation, you have siloed all your knowledge. Those 2 or 3 people, they know everything about the system, but nobody else knows anything about that. So you're kind of digging your own hole here. On top of that, that's the symbol on the right here. We really pay people per page if they are on call. So last year, there was a great talk about how stupid that is, given by A. Niall Murphy. So we had a great laugh last year. But unfortunately, SoundCloud is doing exactly that. And one of the reasons is you are almost legally required in Germany to do that. And I guess there are similar regulations in other countries, so it is careful legal navigation to get around that. So the problem is people are on call all the time, they might not like it, but they get paid for that, they get paid per page, so they're kind of suddenly like noisy pages, they have siloed all the knowledge, and there's no way out of there, right? So 3 years later, SoundCloud is still alive, we haven't drowned in operational works, and we actually had the most reliable quarter in our history. And that was also the quarter where we had the most features. So we must have done something right, and that's what the rest of the talk is about. So this is, by the way, not about the purely technical part, how to manage this. This is also not about how you organize your on-call rotation, because there will be a panel later today led by Laura, so this will be super awesome. Anyway, this whole monitoring alerting track seems to be super awesome to me. So that will be interesting. We will focus on alerting, and the first thing we should get right, what are alerts at all? And there's what it starts. Like, I'm biased, I'm a Prometheus person, so for Prometheus, alert is anything that goes through the Prometheus Alert Manager. The SRE book has a different term. The SRE book calls it monitoring output. So 3 kinds of monitoring output. And this is, it might sound quite obviously what's on this table, but perhaps it's also surprising. So the first kind of monitoring output is the one monitoring output you have to act upon immediately. That's called a page. I call it a page. We call it a page at SoundCloud. SRE book calls it alert. Okay. So it's delivered to your pager, and if you get something delivered to your pager and you don't have to act immediately, it's not a page, it's a bug in your alerting setup. That's really important. I mean, this is already half of the lesson, right? If you have realized that. There are alerts that don't require you to act immediately, but you should act on it eventually. And those are called tickets in the SRE book. We also call it tickets at SoundCloud. Many still call it, deprecated name, email alerts. That's an unfortunate name because email is really the worst way of delivering an alert. It should be delivered to your issue tracker like Jira or some kind of ticketing system, because then you can assign it to people, you have an audit trail and everything, people can report when they work on it and declare it solved. So that's really good, you have this distinction, and then perhaps surprising, there are also alerts that you don't have to act upon at all, right? No expected response. This is for diagnostic purposes. The SRE book calls it logs, which I find slightly confusing. But anyway, I like to call it informational alerts, and that's something that's delivered nowhere, but you might display it at dashboards. It's kind of the dashboard version of alerts, and that's really helpful to diagnose a problem, but this is something you never want to get bothered by if you don't have a problem to diagnose. Okay, so this is half of the lesson. If you realize what that means, you have already half won, so the rest of the talk is like how we apply that, how you get to proper pages and proper tickets and everything. So now, quote from the Holy Scripture, every time the pager goes off, I should be able to react with a sense of urgency. I can only react with a sense of urgency a few times a day before I become fatigued. Every page should be actionable. So we already knew the last sentence. So it's also really important, you never should get paged all the time. If you get paged all the time and your system is legitimately broken, you have to fix your system. This talk is not about fixing your system. This talk assumes you have a sane system, but your alerting is still noisy. What to do then, right? So, true story from SoundCloud. One morning on a Saturday, SoundCloud was down. We have actually improved our alerting quite a lot, so we got a page that said the site is down, essentially. The engineer on call saw that page and had a party last night and looked at the page and said, this was this noisy page that paged me all week, and I already know I cannot do anything right now, I will deal with it later. Act the page, went back to bed. So, the page was act, so it didn't escalate to anybody, but we can't even blame that engineer because he was educated that pages are noisy and don't require you to act immediately. Also, later, someday, people realized everything is down and you got some other alerts firing. Somebody literally wrote in the postmortem, and we corrected that then, this outage was so bad that more pages should have fired. So people got educated that the severity of an outage can be measured in the number of pages you get. Clearly bad education, right? So, let's see how you can get this less noisy. What versus why is one of the most important distinctions in writing good monitoring with maximum signal and minimum noise. So this is kind of the other 30% of the lessons of this talk. Symptoms versus causes. A symptom is something like you serve 500 to your user. The cause might be anything. In this case, this is a table from the book, a database is refusing connection, right? There are more funny symptoms and noises. You can read that up in the book. Important thing is symptoms are the one thing you should page people on, not on causes. Why so? Because causes, first of all, you can't anticipate them all. Your system is really innovative in inventing new causes. So you have to alert on the symptoms anyway, because that's what matters. But if you alert on the symptoms, you don't have to alert on the causes anymore, because you will be waking up when you're needed, and not by noisy causes, or even there might be causes that your alerting doesn't even catch. Okay. Why is this new, right? What I just told you sounds totally reasonable. Why is this a new thing? And my take on that is that in the old world, causes and symptoms were just so tightly coupled that you didn't bother. In the new and modern and distributed world, causes and symptoms are decoupled. We cannot alert on a single machine failure, because if you have 1,000 machines, it will happen all the time, and your system will cope with it. You have designed, with a lot of work, you've designed your system to cope with single machine failure. Now, why should you get paged on that? In the old days, it was clear if I run my web forum on a single Apache server and that server doesn't ping anymore, and my Nagios check tells me the server doesn't ping, yes, I'm down. I should wake up and fix it, right? Not true anymore. We also alerted on silly things like load average. I guess, we still have load average checks at SoundCloud, but I guess you will have, or half of you. It's not even a cause, right? It's just silly to alert on load average. More complicated stuff is something like capacity. My network, my CPU, my RAM, my disk is fully utilized. That's a good thing, right? I paid a lot of money, so I want to utilize them. But then I get alerts that 80% of my disk is used or something. So that's a hard one, how to get this properly. We will talk about that. First of all, technique, let's talk about Blackbox versus Whitebox monitoring. All the cool aid about symptom-based alerting, that kind of sounds like we should have Blackbox monitoring, because that's probing from the outside. You don't need cooperation from your monitored system. You do something what the user is doing, so you should see symptoms. That's true, right? Whitebox monitoring, on the contrary, this is when you instrument your code and you get internal state into your monitoring system. That sounds really like causes. So Whitebox monitoring for causes, Blackbox monitoring for symptoms, so you should only page on Blackbox monitoring, and Whitebox monitoring is for investigation or something. Open the book and you will realize, wow, Google uses just a tiny bit of Blackbox monitoring, and they heavily use Whitebox monitoring. That might be surprising, but there are reasons. The one is that ideally you detect a symptom just before it affects users. That's still a symptom, and that's still worthy a page. Right? So, and for that, you really need Whitebox monitoring. Let's look at some more pros and cons. So, the one thing is, Blackbox monitoring you might think sees the system as the user sees it, but it's not entirely true, because you have designed your Blackbox probe in a way, and that might not mirror your current user traffic. Famous example, a track goes viral on SoundCloud, everybody wants to listen to it, and then the S3 bucket falls over or something, and then nobody can listen to that track. But my Blackbox probing track is the test track with the beep or something. Still plays nicely, right? So there might already be a problem there. And then, was already mentioned, tail latency is super, super, super important in distributed systems. And tail latency and also rare failures, to detect them with Blackbox probing, you need a lot of data. You can say over a year how many nines you had or something. But the question, what's my 99.9% latency over the last 5 minutes, cannot be answered by Blackbox probing. Okay, so there are already some problems. Now, Whitebox monitoring might lie to you. We've seen that in Sebastian's talk. You are, after all, putting the cat in charge of the cream, right? If you ask a binary, so how are you doing? How are you serving? Yeah, great. 10 milliseconds for everything. So yeah, might be a lie. On the other hand, you can ask that binary, what do you think about your backends? And that is totally possible with Whitebox monitoring, and this is actually pretty good. That's kind of probing with live traffic, because the front end will always blame the backend, right? But you get a true response. Now another thing is it's like too good. Like if it's like a hammer where everything looks like a nail and people might instrument their code. I mean, it's always good to over-communicate with metrics, but you should resist the temptation to alert on like random things. If the developer thinks this process should run 20 threads and it runs 30, should you page somebody? Probably not. So now, indispensable to detect imminent problems, we already had that, and also to investigate causes. So 2 things here, imminent problems and investigate causes. Let's talk about imminent problems first. So imminent problems is various things. You all know the famous N+1. At Google scale, that means like a whole data center should be there as a resource buffer, essentially. And if you don't have that additional data center, your users are still happy. You just know if the next data center goes dark, I have a problem. So that's something you should wake somebody up, because you want this redundancy, and this is something you can only detect with Whitebox monitoring. Also, there might be more complex case-by-case reasons, because you know how the binary works, so you can detect something that clearly signals there's an imminent problem. It's sometimes difficult to detect, but it might happen. And then there's this hard part, the almost fool scenario. Nearly fool, whatever. So this is where time series-based monitoring gets into the game, where you can see trends, and that's really important. And as you can read in the book, this was something Google is doing for quite some time, but in the open source world, you have all those new and shiny things like Prometheus, Riemann, Hacker, and Boson that can do that, and that's really great, but it's pretty new for like normal mortals outside of the big G and stuff like that. So let's quickly look what that means. This is the classical Nagios disk full scenario. So you have a pretty conservative threshold of 85%, and if any of your disks go above 85%, you page. So on the left, somebody has like money saving everything, uses 95% of the disk or something. It's good. It's like floating around. It's totally fine, but you get paged all the time. On the left side, this is what like Nagios thing is totally fine. You have a steep increase, and you know you can already see pretty early this will hit 100%, but Nagios will only tell you like a couple of minutes before. That's, by the way, the reason for having this super conservative threshold of 85%. So you have a bit of time in case of a steep increase to intervene. So that's kind of both bad, right? So now with a time series-based monitoring system, you can actually look at the trend and you can extrapolate, and you can say, okay, if it's floating around 90% all the time, that's actually fine. And if you have a steep increase, oh great, I can alert 4 hours before that happens. So this is just an example. It gets way more complicated. You have seen, like in the other talks, you can analyze graphs into the ground, but that's the idea, right? So now causes. True story now from Google. The stats processing pipeline, Niall already mentioned in his talk. I was on call for that as well, even before he was. And we suffered a lot because that was a huge contraption of like hundreds of different little binaries, and the developers all had very good idea if one of those binaries throws up. And you got alerts all the time, and most of them you're just watching at that thing and waiting, and it kind of got right after a while, and then you went back to bed. So bad, right? So we drank the Kool-Aid of symptom-based alerting, and the only symptom that matters in a processing pipeline is the pipeline delay. So there was all those pages replaced by 1, and that was pipeline delay is high. 3 days of blissful silence, and then we got the page. Pipeline delay is high. Great, let's do something. And you stood in front of this giant Rube Goldberg contraption, and you were, what is wrong now? I don't know, like the pipeline delay is high. And then you wanted all those alerts back that tell you, yeah, this one task is overloaded and all those things, right? So causes are actually good. They are good to investigate what's actually going wrong, but they should never go to your pager if you can help it. So you want informational alerts, which is kind of the new idea here, or you want sometimes even tickets if like a single task is overloaded all the time. It doesn't cause a problem right now, but you might want to look into it to like prevent future problems or something. You don't want to get woken up by that. So causes important too. So symptom or cause, that's an interesting case because in a multi-layered system, one person's symptom is another person's cause, quote from the book. So this is really interesting, especially microservice architecture. You want this independency of teams, so it kind of makes sense that they are my users and I'm a user of them. And then you might also want to page on that because you see them as users. So drawing the line is not always easy. You should put some thought into it. We will have a talk, Bora, my colleague, will have a talk about SLOs for microservices within SoundCloud. That was a nice move, so we created SLOs, so now we could by one general alert expression, we can, like, in the whole company, alert teams on breaking the SRO. That's pretty good, right? Symptom-based. Okay. So now this is the tool chain development at SoundCloud. Just to look at that, as said, you can implement this with many tools. Obviously, we used Nagios in the old days, and it's a black box monitoring system, so you might think it's pretty good for service, for symptom-based monitoring, but it's so host-based that it's really hard to get it right to monitor services instead of just hosts. Stutzy was a great step forward. It's a Whitebox monitoring system, by the way. It's not really an alerting system. You have to feed the data into Graphite, and then you have weird Nagios checks that check Graphite again, so it's a bit fragile. It also has some technical issues. But yes, it was a great step forward, but it had this problem that you could alert on symptoms pretty nicely, but it was difficult to explore once you had an outage what's actually going on. And this one sentence from the book is so nice because it distills the motivation we had when we created Prometheus. We need monitoring systems that allow us to alert for high-level service objectives, but retain the granularity to inspect individual components as needed. Having both of that consistently in the same system, that's really what you want. So we got into this Prometheus game because there was just nothing else back then. Hashtag monitoring sucks. That was the open source, state of the open source world. Has improved a lot. Like, we have so many super nice new tools now. Prometheus is a Whitebox monitoring system. We also do a bit of Blackbox probing by now. I put the black flame there, so there's a component, the Blackbox exporter. Brian Brazel wrote it. He might be in the audience. He's in the organization team of the conference. So, so we're doing that a bit, and we're still running Nagios, but we have a trajectory now that we might finally get rid of it completely. So that's pretty nice. Okay, anomalies. I put this slide here because I thought I was totally looking forward to stir up a controversy. My take is paging on anomalies as an anti-pattern. And I saw Dieter's talk and I thought, yeah, let's fight. But no, Dieter had almost exactly the same slide with almost exactly the same quotes from the SRE book in his talk. So no controversy. Fortunately, this is all good. Anomaly detection is actually great. But you should never page. You can use it to study your system to get, let's say, tickets or informational alerts, but this is the important thing. You should never do that, and Google doesn't do that, right? The path to a page is usually simple, no magic involved. Like, the biggest machine learning company in the world tells you that, so you should take it seriously. So, silencing, just 3 more items to mop up here. So silences, this is trivial, right? You should never get paged if somebody wanted to silence that page, but it happens all the time. At least with Nagios, you can silence anything with Nagios. It's technically possible, just nobody knows how. And we got we got so many pages, like, we had times where half of the pages I got were just missed silences. And so this was a huge thing we wanted to fix in Prometheus. So Prometheus is label-based, and you can silence along labels, which makes it really simple to say, silence this whole data center, silence this whole server, silence everything that comes from that host, stuff like that. And nowadays we have very little spammy pages that should have been silenced. Okay, then this is actually 2 topics, runbooks and robotic responses. They seem unrelated, but there's a nice connection. So I talked about siloing knowledge, and then you have those small on-call rotations you can't extend. Of course, you should know about the system you're on call for. You don't want pager monkeys that don't know about the system they're on call for, but usually you're on call for many things, and you can't know everything like 100%, and it's nice to have a runbook, which you can use as a pointer. Google calls it playbooks, and people might call it differently, but this is all the same thing. You want something that gives you a pointer, okay, if this outage, if this page fires, what's going on here, where can I start, what do I have to investigate? Also, you could put ephemeral information there, like if you have already investigated that and you suspect it could be that, so if it happens again, please look up this bug or something, or a bug me or something. You could put all of that into this runbook, should be ephemeral, like a wiki or something. Yeah, so the connection to robotic responses is, if your runbook reads like a shell script, turn it into a shell script. and don't get paged, right? So this is the nice thing, which is also in the book. Every page should require intelligent. If a page merely merits a robotic response, it shouldn't be a page. And this is kind of your litmus test. If your runbook is a script, it's probably a script. So this is how it looks on the Prometheus alert manager. This is how we display alerts. You see there's a runbook link there. You can just click on it, even like a dynamically rendered link to a dashboard, which shows you meaningful information. So that makes it pretty easy to get into treating an alert you are not super trained. Okay, now we are at the end, anticlimactic ending. You have created the perfect system. It never pages. You have eliminated all the noisy pages. Weeks of blissful silence, and you have time to read the SRE book. You open it and you read the sentence, an operational underload is undesirable for an SRE team. All that work and then it's undesirable. So what's the problem here? If you get paged, it's free training. But if you don't get paged, you might forget about what the system actually, how do I handle an outage, right? So this is when you want game days, as we call it at SoundCloud, or DIRT, as Google calls it, disaster recovery training, wheel of misfortune, that's from the book. In ads, we called it wheel of poverty, actually. So you want those dry run trainings. That's really important. It's also great stuff to onboard more people on your on-call rotation, so solves all those things. Which leads us to the final quote from the book, may the queries flow and the pager stays silent. Thank you.